All right. This is example 3A from the notes. Now, this is one we did not get to. So here we have it worked out, and I will explain it. So we are finding the instantaneous rate of change at a value. So here we have the S sub t. So again, just to remind you, that is what we call a position function. So in this particular case, we want to find the limit as t approaches 0, and the limit again is described as a derivative, and we want to know the velocity at t is equal to 0. So again, position function, velocity, they go hand in hand. Here we go. The initial definition is we have the position function at that change in t minus the position function at t, and then we have it over delta t plus delta t minus t. And of course, if you notice, that t and that minus t go to 0. So we can go ahead and simplify that right away. Now, we are putting the t plus delta t where we see the variable t in the function. So when we're looking here, this position right there is where we are inserting the t plus delta t. So this is where we have this inserted into our function. So we have that -4 and the -6. So that's plugging in the t plus delta t, and we're squaring it. And then we are subtracting that original position function. Now, again, I've talked about this a couple of times, but I want to be sure we can handle this. That squared, again, you guys, is FOIL. So we've got to be able to do that. And what we end up with, we still have that -4, and then we end up with that t squared plus 2t delta t plus delta t squared minus 6. And then when we distribute that negative to our function, these change to 4t squared plus 6. So this is supposed to have a negative in front. When we have that, if you notice, the -4t squared cancel out with the 4t squared. They go to 0. This -6 and the +6 goes to 0. So what we are left with is the 8t delta t plus the 4 delta t squared all over the delta t. And of course, we always have to write the limit heads to 0. We always need to do this proper notation. Now, you can look at this. I know we've talked about this with other ones, that the delta t's all will cancel out in each term. The other way to do this, which is actually my preference, is you would factor out the delta t from those terms. So we would have 8t plus 4 delta t left over, and all over that delta t. And what happens is that goes to 1. Remember how I don't like you to use the word cancel? Because actually what is happening is the delta t over delta t is 1. So now, we have the limit as delta t is headed to 0. So right here, we can see that if when we plug in 0, that term is 0. So we end up with the 8t, the function 8t. The last part of this is we want to know what it is when t is equal to 2. What do? We plug that 2 in for the t, and we end up with 16. Now, what are we talking about for units here? My guess is it's feet per second. Let's just assume that's what it is. And that's what our units would be. So this is example 3A. If you have any questions, let me know. See you next time.